In Chapter 11, we learn about chemical reactions. Reactions occur every day and every second. They all involve a changing of a substance. Reactants are products in itself. A chemical equation is a short handway to convey chemical reactions. For example, iron rusting. The little letters next to the elements like S, G, and S are states of the elements. The whole equation is a skeletal equation. A catalyst speeds up the reaction but is not consumed. Balancing equations. The law of conservation of matter states that matter cannot be created or destroyed. A balanced equation equals the same number of atoms on both sides. A coefficient is a whole number put in front of formulas to balance atoms. For example, 4Fe plus 3O2 equals 2Fe2O3. 11.2 is types of chemical reactions. There are 5 types and some overlap. Number 1 is combustion, in which the compound/element reacts with O2 and produces heat. An example of this would be 2C8H18 plus 25O2 to 16CO2 plus 18H2O. So 2Mg plus O2 combines with 2MgO. Number 2 for types of chemical reactions is combination. Combinations means 2 or more substances form a single new substance. A perfect example would be when 2Mg plus O2 combine to make 2MgO. Number 3 for chemical reactions would be decomposition. Decomposition is the reaction in which single compounds, breaks into two or more products. A perfect example of this would be 2H2O2 combine to form 2H2O plus O2. The fourth type of chemical reaction is single replacement. In single replacement, the reaction in which one element replaces the second element. An example of this would be when Zn plus CuNO3 combines with Cu plus ZnNO3. The final reaction is double replacement. This reaction in which the positive ions exchange between compounds. A great example of a double replacement reaction would be when Na2S added to CdNO3 combines with CdS plus 2NaNO3. In Chapter 13, Section 3, we're learning about aqueous solutions. And aqueous means H2O, which is water. In aqueous solutions, double and single replacements. Aqueous solutions are the cation and anion split up. An example of this would be NaCl aqueous combined with Na plus aqueous plus Cl minus aqueous. Examples of aqueous solutions and how to solve. AgNO3 aqueous plus NaCl aqueous combines with AgCl solid plus NaNO3 aqueous. The goal of this equation is to write the complete and net ionic. Step 1 for how to solve these is to balance the equation. After you balance the equation, step 2 is to complete the ionic, which means to split up everything that is aqueous. So for this equation, we would have Ag plus aqueous plus NO3 minus aqueous plus Na plus aqueous plus Cl minus aqueous. Can't squeeze that in. And then we'll have them combine with AgCl solid, so we don't split up the solid, plus Na plus aqueous plus NO minus 3 aqueous. Now we cancel out the like things like this, and NO3, and NO3. So then step 3 is to solve the net ionic by canceling spectator ions. The final equation would be Ag plus aqueous plus Cl minus aqueous combines with AgCl solid.